Let's go to LeetCode 995. Minimal number of k consecutive bit flips. For this question, it gives us integer array nums, and for the nums, it has only one or zeros in it. And it gives us a sliding window k with size k. So what the operations we do is that, for example, if there is 0, 1, 0, 0, 1, 1, 0. For example, we have a sliding window, for example, k equals 3. What we need to do is that for this kind of sliding window, we can flip those kind of zeros to, in the sliding window, we should flip 0 to 1 and 1 to 0. So, for example, we have changed this one to 1, this to 0, and this to 1, right? And then our sliding window can go to this kind of range. And we find out 0 here, right? So we are going to flip this one as 0, 1, 0, 1. And then we move forward, right? So it will be 1, 0, 0, right? And then the next round, we should flip this, should be 1, 1, 0. And we'll see if our window moving out, right? We are not able to flip all of that that array to be 1, 1, 1, 1, right? So in this case, we are going to return -1. But if, for example, if we have another 0 here, right? And we can use another flip. So that to change all of these zeros to be 1, 1, 1, so that the arrays are all become 1, right? So we count how many flips we need. So there is 1, 2, 3, 4, 5, 6, right? So it will return 6 if in this case. We'll look at the data range has array has size 10 to the power 5s, and k has 10 to the power 5s. So if our strategy is that if we just iterate those kind of I from 0 to n, right? And then we're trying to see in this kind of I from I to I plus k, right? To flip every number in the range. It will be an O n multiplied by k time complexity, right? So that one, it will TRE. But for this kind of question, we find that we may not need to do for every window trying to flip those kind of 0, 1, 0, 1 in it. So what we're thinking about is that we just need to just when we find out a 0, right, in one kind of round, if at this time this is a 0, we want to flip. So what we can flip is just in the window from the I to I plus k minus 1, right? So all the data in this kind of range is flipped. And so, and also, so if we, so all of this kind of data is flipped. So what we're thinking about is that we actually only the index at the beginning and the index posted at the end we can try to record those kind of index at the beginning and the index at the end, right? So if we flip, we'll say for this kind of range, it flip once, right? And so what we're thinking about is that those kind of data, whether they are 0 or 1, are determined by one is originally what this kind of num I it is, and another is how many flips it happens for this kind of index I, right? So if there is a flip, what we're thinking about is that we can have use a plus sign at the index I and a minus sign at the index I plus k, right? That means for this kind of range from I to I plus k plus 1, we are add one more flip, right? So this is pretty much like a diff array, right? So that means if we want to calculate for how many flips from the left to right, right? So if we see entering events, we'll say all of the next data, the flips will add 1, right? And if we see leaving events, right, that means all of the flips are subtract by 1. So in this case, we know that we don't need to calculate every number to flip it, right? Because we just need to, if there is a flip, we just need to add 1 at the index I, right? And what we can do is that every index after I will be the same flips with those kind of flips at index I until there is a new entering or leaving events, right? So we call this kind of started slide window. This is entering events, and this is leaving events. So if there is no entering or leaving events, we will say those kind of flips, they are the same as the flips at the index I, right? So what we're thinking about is that we can do something like a diff array. And we can have a global flips counts, right? So if we are entering a slide window k, right? We need to do a flip. We will have flip counts should increase by 1, right? And if the thing is that if we are entering at the I plus k minus 1, right? Then our flips accounts should minus by 1, right? So so we know so this is the main concept, but when do we need to determine we need to flip, right? So if we have a global variable called flips, we enter in here, we see for this kind of data, how many flips it's already taken, right? For example, this kind of flips, if it is an odd number, that means all of the data at its index for example, we'll say index L, right? The data has been flipped. For example, 0 already changed to 1, right? Or 1 changed to 0. So if the original data is 0, that means at this stage, it's already changed to 1, right? We don't need to flip again. But if all of the data, for example, original data, it is 1, right? And if we see this flip count is an odd number, that means this data is changed to its opposite, right? It's changed to 0. So if we see a 0 here, right? That means for the previous flip counts, this number becomes 0. Then we need another flip again, right? That means we need another sliding window here. It's from, for example, this L, right, to L plus K minus 1, right? So what we do is that we also have an diff array, have L plus K should minus 1, right? So the thing is that because we don't, as long as we enter an sliding window, right? So we'll see we'll have +1 here and -1 when we finish the window, right? Actually, we don't use this index I anymore, right? So actually, we just need to have a flips count global variable. Should be enough, right? So let's begin to write the code for this kind of diff array approach, right? So we'll say we'll have int n equals nums dot length, right? And we'll have so if we have diff array, we call diff. That means we entering flip sliding window, right? Or we are leaving flip sliding window, so that we'll have new int. Let's set this one as n plus 1, right? Because for the last one, if we sliding window is at n minus 1, right? So we want to say this kind of unflip is at n index n, so we can have our actual index here. So what we do is that we need a global variable, right? So that otherwise we in the diff array we need to always have it is like a prefix sum, right? For the entering events we should +1, but we need to calculate if we +1 how many flips already have, right? So we can use a flip counts variable here, right? So what we do is that we have int flip count equals 0, and we need a result, right? How many flips total? Actually, do we need this? We don't need a result, right? We just need a flip counts. So what we do is that for int I equals to 0, I smaller than n, I plus plus. So for every flip accounts, right? Flip counts, I should plus equal to flip diff I, right? So so that if there is a leaving event, right? So for example, there is a sliding window finished, our flip counts, we should decrease by 1, right? In the yeah, so that we because the thing is that if we have sliding window flipped here, right, and this kind of diff array is maybe recording a previous run. So we'll say if this kind of flip counts mod 2, if this is equals to 1, right, that means if we flip the odd number and nums I equals 1, right, that means we'll change the for this kind of number, it is changed to 1, right? And also we'll say if this is an even number, right? We'll call it flip f count, right? Then that means after this kind of flip, this index I, it is 0, right? So we need another flip, right? Then we'll have actually we'll have flip I should plus equal to 1, right? The diff I should be plus equal to 1, right? And we'll have diff what? Diff I plus k, right? Should minus equal to 1, right? And we have another flip here, right? So flip count should increase by 1, right? And we should return flip count, right? So this is intuitively what we think about the logic, right? But we need to think about how can we improve. The thing is that the first is that we'll see if in the last window, for example, I plus k is already greater than n, right? And we find that now there is a 0 here, right? That means we don't have a k window size big enough to as k to flip this kind of number anymore, right? So that means we should return -1. So we should have if I plus k is greater than n, we should return -1, right? And also for this kind of code, right? We can also simplify it, right? Because and this one we can simplify as this. If this one XOR nums I equals to 0, right? So that's the same thing as we discussed in the 2 scenario. So Flip counts. Sorry. I think we still should have a result because this flip counts is just a local variable, right? To mean how many flips at the index I, right? So for totally how many flips we have, we should still have a result, right? So this result is just the recording on the flipping part, because otherwise you see if there is a -1, this kind of data is decreasing, right? So we need to still have a total result equals 0, and our result should increase, right? Should increase by 1. And the things that we'll see this kind of diff array we are not use anymore, right? After we we already increased by 1, right? And we calculate here. So this kind of line is not used anymore, right? So it is actually entering events, right? So this is the variable for from the index I, it's increasing by 1, right? So as this variable we don't use it anymore, we can remove it, right? In the end, it's not a returning f count, right? Because the f count is a local variable to tracking at index I how many flips. We are trying to get the total how many flips we have, right? So we should return result. So this will be the code, right? Actually, for this one, we can simplify it more, right? Because for the diff, there is it can be, in this case, it is possible that we trying to have increase by 1, right? Actually, it is not possible to have 2 because it's already calculated. This slide to the next window, right? But the thing is that for this kind of flip, the 1 or 3, they have the same effects, right? And 2 and 4 have same effects. So what we can do is that instead of plus equal, right? We can just have all equal, right? And then we'll just have diff I plus k minus equals to k, right? So this one actually because we are using all, right? So set this one as -1. Or we put this one as 1, right? That is same effects because this slide window will not go back to, we are only calculate once, right? And also here, if we use XOR, right, then our flip counts we don't need to increase, right? So we can also use XOR equal to 1, right? If we do this, we don't need to have this to mod 2. So we can just so because in this case this f counts variable can only be 0 or 1, right? So we can change this one more. And after, so doing like this, the time complexity will be O(n) right? So instead of okay, it will be all in time complexity. Let's write a Python code for this as well. So let's say we have n equals length nums, right? And we have flip equals 0 multiplied by n plus 1. Okay, because for the diff array, right? We want to calculate also calculate the last one, right? Because actually when there are entering events and leaving events. Leaving events is at for example I plus k, right? So this is the last one is I plus k minus 1, right? So if our window end at n minus 1, our leaving event is at n, right? So we have an extra space here. And then we have f count, right? F count, that is just among I made a mistake. This is not the total result, right? Because this f count is dynamically changed, right? It just represents at this kind of index I how many flips we have, right? So for this kind of nums I, how many flips? It is a global flip counts. And if there is a leaving events, right? This f counts should decrease, right? So we should have both f counts variable and the result variable. And also for this question, right? If we simplify it as bits 0 and 1, right? F and counts will only be 0 and 1, right? So that will not be the result. Will even have discrepancy with the result, right? So it's better we have two variables. And we have result, right? Equals 0, 0. And then we're going to have for I in range n, right? So we are going to have f count to the XOR the diff array, right? Let's call it a diff, the diff array. And we'll say if this f count XOR nums I, right? If this one is 0, that means our flip counts, right? This may be an odd number, and originally this is a even number, right? For the for example, we flip the ones, right? And originally this is 1, right? Then this one changed to 0, right? So the same thing, right? If we have this flipped twice, right? And original this is 0, right? This is also 0, right? So doing like this, we don't need to worry about it's odd or even, right? In this case, that means this nums at this run, this kind of nums it's 0. Then we need a flip. So we're going to have flip I plus k should actually in the diff array we should write a minus equal to 1, right? But to put this one as 1 should be fine, right? Or plus equal to 1, right? Because this slide window will not calculate twice. And we may only there is entering events. It's possible it's calculate twice, but that is only when in the later part I plus k there is entering event. That means when we iterate to I plus k, it flips to 0. It may still be 1, right? But for this kind of scenario, 1 and -1, they have the same thing, right? So we put this one as 1. So or you can write a plus equal to 1, it will be the same. And we'll have a result should be plus equal to 1, right? And this one, we calculate the total result, right? So it will, we cannot just write equals to 1, right? So because we need to find how many results we have, and we have flip counts to the X or 1, right? So this is actually at diff I, we increase by 1, right? So the one after I should also increase by 1. So that is a similar logic here, right? And in the end, we need to return result. In here, there is the last window, right? If I plus k is greater than n, right? That means it's not achievable. So we'll return -1.